Continuing on the trend of electrolysis, for MCQ 14, we want to find out which electrolyte gives us the formation of a metal at the cathode. Now when it comes to cathode, especially if we are tasked to find out the products of an aqueous electrolyte. The term aqueous would have suggested the presence of H+ that comes from water that can interfere with the discharge of the metal cation that is found in the electrolyte itself. Now, when given two cations, we need to then rely on the act of selective discharge that takes place at the cathode. And when it comes to selective discharge at the cathode, there is only one rule that governs it, and that will actually be to select the one that has the lowest reactivity. So doing that, we should be putting in our metal reactivity series. The shortcut that was taught in class, we have please, send, Charlie, monkey, and zebra in tall, lead, hunting, cages, securely gated with padlock. Platinum being the least reactive metal and potassium being the most reactive metal. So in water, H2, which is representative of H+, is present. So if we want to selectively discharge something in the presence of H2, it could only be the presence of copper 2+, silver+, gold+, or a platinum cation. We often do not have platinum cation for consideration here, so we should be looking out for copper, silver, and gold if it was an aqueous solution. However, in the case of us dealing with a molten solution, then this is going to be much easier because in a molten solution, there is no H+ from water, and in the absence of H+ from water, we only have the metal cation for discharge process. So we won't even use the term selective discharge, we'll just use the term discharge. So taking a look at the first one here, copper 2 bromide aqueous solution, the cation present is copper 2+ and H+. But since copper is less reactive as compared to hydrogen, we will be selectively discharging copper. And this gives us a metal at the cathode. Option number 1 should have been included. So A and B are the potential correct answer, but no for C and D. Now for number 2, we're using concentrated aqueous sodium chloride. So that's Na+ as well as H+. Now the amount that is within, whether it's concentrated or diluted, will not be a concerning factor for us at the cathode because concentration is not one of the points of selective discharge, but rather the reactivity series of the metals itself. But since sodium is way above H+, we will be selectively discharging H+ instead of sodium. And this leads to the evolution of hydrogen gas, which means that option number 2 will not be inclusive because it does not give us sodium, but rather it gives us H+. So the correct answer is really going to be B over here. But continuing on, we're going to take a look at number 3, which is dilute sodium chloride. Similarly, even if it's diluted Na+ and H+, we will still be selectively discharging H+ because sodium is more reactive as compared to H+. So writing out the equation at the cathode, is going to be another 2H+ plus 2 electrons to give us hydrogen gas. Now for the fourth option, we're looking at the usage of molten aluminum oxide. Because it's molten, there's the absence of water, and in the absence of water, hydrogen will not be interfering with the selective discharge process. Only aluminum 3+ is present. Make sure to put a bracket L because it's molten. So the half equation we should be expecting is going to be aluminum 3+ molten plus 3 electrons, and this will give us aluminum with another molten, because since this is a molten solution, it's way above the melting point of aluminum. So instead of getting solid aluminum, you will get molten aluminum. This is very much reminiscent of what you should be seeing in the blast furnace. Either way, we are also producing a metal which is according to what question 1, and option 4 is correct as well, giving the answer as B for this question.